Hi everyone, this is Nina and welcome back to another episode of Youth Datathon Survival Guide. So today, the code will be about predicting answers. The provided code aims to analyze a multiple choice exam scenario. The code begins by generating all possible combinations of answer choices for a given number of questions using the intertools product function. It then calculates the score for each combination by comparing the answers with the correct answers. The code further determines the combination that yields the maximum score, representing the predicted answers for achieving the highest possible score. Additionally, it calculates the total number of possible combinations and the expected score for the entire exam based on the probability of selecting the correct answer and the scoring criteria. In the second part of the code, it uses binomial distribution from Scrpy stats module to compute the probability mass function for different scores in the exam. It then calculates the expected scores for each possible score and determines the overall expected score by summing up these expected scores. Overall, the code provides insights into the possible combinations of answers, scores, and expected scores in a multiple choice exam setting. It helps analyze the impact of answer choices and scoring criteria on the expected performance of exam takers. So now let's go to the code. The first line that's already been written imports the intertools module, which provides various functions for efficient iteration and combination generation. N equals to 10 represent the number of questions. K equals to 4 represent the number of answer choices for each question. This line creates a list named answer choices with the available answer options. Here we're just using A, B, C, D. Now, this generates all possible combinations of answer choices for the given number of questions using the intertools product function. This calculates the total number of possible combinations using the formula k raised to the power of n. Create a list of correct answers for each question. Now initialize an empty list named scores to store the scores for each combination. So now this for loop will iterate over each combination of answer choices. This will calculate the score for the current combination by comparing the answer choices with the correct answers. Add the calculated score to the scores list. Then find the maximum score achieved among all combinations. Retrieve the combination of answer choices that corresponds to the maximum score. Now print the predicted answers that yield the maximum score. Calculate the total number of combinations using the formula k raised to the power of n. In this case, it will be 4 to the power of 10. Import the math module, which provides mathematical functions and constants. Calculate the number of possible combinations of answer choices for all questions using the formula for combinations. And then you print the number of possible combinations of answer choices for all questions. Calculate the expected score for each question by multiplying the number of points per question answer, 2 in this case, by the probability of selecting the correct answer, which is 1 out of 4. Now print the expected score for each question. Calculate the expected score for the entire exam by multiplying the expected score per question by the number of questions and the number of possible combinations of answer choices, and then dividing it by the total number of combinations. And then print the expected score for the entire exam. Now perform a calculation of dividing 17.303466 by 20. Now for the binomial distribution, you import the Skippy-Stats module, which provides various statistical functions and distributions. Then set the value of n to 10, representing the number of questions, and the value of p to 1 over 4, representing the probability of selecting the correct answer for each question. Set the value of score to 2, representing the number of points awarded for a correct answer. This line calculates the probability mass function of the binomial distribution using the Skippy-Stats binom PMF function. It computes the probabilities of obtaining different scores, ranging from 0 to n, in a binomial distribution with parameters n and p. Then calculate the expected scores for each possible score ranging from 0 to n by multiplying the PMF values with the score. Calculate the overall expected score by summing up the expected scores for each possible score. And now print the overall expected score. And now you press run, and there you have it. Thank you so much, and see you next time.